So this is the problem that we did in another video. This is in the lab frame, or the problem frame. So what an alternate method is, I'm going to shift this into the zero momentum frame, so 0p frame. So we have to figure out how do we do that. And so as before, you basically look at it as if it's perfectly inelastic. Well, actually, let's do it the formal way. So I'm going to shift it, so 5 times 2 minus v plus 3 times negative 4 minus v equals 0. So basically, I'm going to shift the velocities by some value of v in order to have a total momentum of 0. So I have 10 minus 5v minus 12 minus 3v equals 0, negative 8v. So I have negative 2 minus 8v equals 0, negative 2 equals 8v, v equals negative 1/4. And so to shift the frames, this is my 5 kilogram mass and my 3 kilogram mass. I start out at 2 and negative 4. I subtracted this value to get to it, so I subtract negative 0.25 minus negative 0.25, and for those who suddenly had a mind burp or brain burp, 1/4 is 0.25. So in essence, I'm adding 0.25, so this becomes 2.25, and this becomes negative 3.75. So in the zero momentum frame before, I have my 5 kilogram mass heading this way at 2.25 meters per second. My 3 kilogram mass is heading to the left at 3.75 meters per second. And then after the collision, because there's no momentum total, after the collision, they have to be bouncing directly opposite each other. So this is my 5 kilogram mass, this is my 3 kilogram mass, this is some angle phi, and just because I was using C and D in the previous video, I'm going to label this E and F. Those are the speeds after the collision. But they do have to balance each other out completely because the total momentum is 0. Because this is a one-dimensional problem, I can get away with just a positive negative. I don't need I hat, J hat. If you want, you can make that the I hat direction. But it's a one-dimensional problem, so I have 5 times E, which is the momentum in that direction, 3 times F, which is the momentum in that direction. So I end up with 5E is equal to 3F. Divide both sides by 5, and I get E is equal to 0.6F. From my energy point of view, I have 1/2 times 5 times 2.25 squared. This is all zero momentum reference frame, plus 1/2 times 3 times 3.75 squared is equal to 1/2 times 5 times E squared plus 1/2 times 3 times F squared. I can plug this in for E. And let's simplify it just a little bit. Let's multiply the whole thing by 2 to get rid of the 1/2. So this ends up being 67.5 is equal to 5 times 0.6 F squared plus 3 times F squared, which is 0.6 squared times 5, which is 1.8. So 1.8 F squared plus 3 F squared, which is 4.8 F squared. So F squared is 14.0625. F becomes 3.75 meters per second, and E becomes, well, multiply times 0.6, 2.25 meters per second. So I have the speeds right there. I don't necessarily need to find the angle now. I need to put this back into the reference frame of the problem. I can't just leave it like that. Also, I don't have an angle yet. So if we think about the two frames of reference here, basically I'm looking at this and then I am running in, so this I'm just standing as a bystander. Now if I run this way at 1/4 meter per second, it becomes a zero momentum frame. All I'm doing is I'm shifting the horizontal components here. I'm not shifting the vertical components. So if I look at this triangle right here, this was C and D, this becomes C times the sine of that, which is 0.6. This is C times the cosine of that, which is 0.8. This right here is d times the cosine of theta, and this component becomes d times the sine of theta. If I shift into the frames here, this is e times the sine of phi and e times the cosine of phi. Now when I shift from one to the other, I'm not shifting vertically, and so I have this relationship of e sine of phi is equal to c sine of that angle, in other words, 0.6c. The horizontal component, well, when I'm shifting from this frame to this frame, I have e cosine of phi is equal to 0.8c plus 0.25. Because remember that I added 0.25 when I went from this frame to this frame. If I'm looking at the other triangle here, similar reasoning. The minus sign is going to get a little bit tricky here for just a moment. But we also have f sine of phi is equal to d sine of theta. And then recognize this is in the negative direction, so I have negative d cosine of theta plus 0.25 is equal to negative f cosine of phi, just to add some nicety to the whole problem. You know, neither technique's going to be so incredibly math-free that it's easy to do. If I'm looking at my triangle here, let's just take a look at the E triangle. I now know the value. I know what my hypotenuse is. I know this is 0.6c. I know this is 2.25. And I know this is 0.8c plus 0.25. Well, Pythagorean theorem. 2.25 squared is equal to 0.6c squared plus 0.8c plus 0.25 squared. So I have 5.0625 equals 0.36c squared plus, multiplying that out, this is 0.64c plus 0.4c plus 0.0625. Let's get this over to that side over there. And so I have 0.36c, that should c squared there. So get this over to the other side, or get this over to the right-hand side. I have 0 equals c squared plus 0.4c, there's a point right there, minus 5. And now, quadratic equation, or actually that is a quadratic equation, quadratic formula. So I have c squared plus 0.4c minus 5 equals 0. This is a quadratic equation, so I need to use the quadratic formula. So I have c is equal to negative 0.4 plus or minus the square root of 0.4 squared minus 4 times 1 times negative 5 divided by 2 times 1, which is negative 0.4 plus or minus the square root of 20.16 over 2. Now there are two solutions, but the negative solution doesn't make any sense because c, I indicated the direction it was going in. C is a speed, it is a positive number. And so the positive solution right there is the correct one, and you can end up with 2.045 meters per second. And I don't care what that other one is. I know it's an impossible solution, but I guess it's officially not applicable. So at this point, I know E and F, and these are the speeds in the zero momentum frame. So that's 2.25 meters per second and 3.75 meters per second. Then I know C, this is in the lab frame or in the problem frame. I still need to find D and theta, but in order to do that, I actually need to find phi also. So going back to what we did before, actually I've already drawn the triangle, but we have the equations right here. I know that E sine phi, so 2.25 times the sine of phi is equal to 0.6 times c, which is 2.045. And so we can find the angle phi. And so sine of phi is 0.54533. And do an arc sine. Phi is 33.047. 34 degrees. Now bringing in the other relationships here. I know that d sine theta is equal to f sine of phi. Well, I have phi, and I have f, so I can actually calculate what the actual value is. And this is 2.04499443207, so on. For my other equation here, I have d cosine theta is equal to, I may as well keep that negative, is equal to negative f cosine phi minus 0.25. And I can actually calculate that out. Negative 3.3933590942. All right, so now what I'm going to do is I'm going to square both sides. I'm going to square these, and I'm going to square these, and then add them together. So I have a d squared sine squared and a d squared cosine squared. Don't forget, negative squared is positive. And so when I add so I'll end up with d squared sine squared plus theta plus d squared cosine squared theta is equal to that squared plus that squared. And so this becomes 4.182 ... plus 11.51466 ... So this is 15.696669. Ooh, evil. 547. That is just d squared. And so d becomes the square root of that, which is 3.96 meters per second. To find theta, well, I have this equation right here. So 3.96 so this number times the sine of theta is equal to that. So sine of theta is just this big number right here divided by this number right here. This is 0.51616. Do an arc sine. And so theta is 31.075 degrees. Now, so the original problem, again, we found the E and F in the zero momentum frame. We found phi in the zero momentum frame, but we need the answer in the lab frame or the problem frame. So that's my value of C, that's my value of D, and that is my angle. And if we refer back to the other video where we actually came up with an answer here, and this was the solution, we have 2.045 meters per second. We had 3.96 meters per second and 31.08. And this actually would round off. There are some other numbers past this, and so this would be 31.08 degrees. And so two different ways of finding the exact same thing.